Students, welcome back. So, part 2 of the lecture number 11. So, we discuss a lot about what kind of material science problems we can use machine learning for discovery, right. So, several examples I given, as you know. First example I gave is this Hume-Noether rules, the classical work of data driven formula, about the substitution solutions. Then we talked about Paris law of fatigue crack growth. Again, the value of exponent can be determined by purely from the data analysis, as you understand. Exponent means m. And we also talked about Hall-Page equation. Here there are two important parameters which needs to be determined. One is the k, and second one is this sigma I. So, sigma I is always known as a frictional stress and k I is the Hall-Page coefficient. So, both can be determined by simple data analysis. Scikit-learn is open source Python library. It can be used by anybody, it is open source, right, and it is always used for building machine learning models. You will use yourself, I know, because this is the first thing one can do when you learn about Scikit-learning. It provides you a range of tools, classification, regression, clustering, dimension reductions, even data preprocessing tools. Please remember that. It is a very, very versatile one. It will simplify all the process of implementation, evaluation, machine learning algorithm, and making it accessible for both beginners and experienced practitioners. If you are starting to learn Python, this is the best thing to do. Since it is open source learning machine learning library, it supposed basically it can support both supervised and unsupervised learnings. It can provide various kinds of tools, not only for modeling, model fitting, data preprocessing, model selections, evaluations, as well as many other utilities. It is built on various kinds of functions. I am only giving NumPy, is basically nothing but a numerical computing Python library. You can also use matplotlib, which is a Python library for data visualizations. Nowadays in schools, okay, class 10, 11, 12 standards, this Python libraries are taught. Even there, the AI books on artificial intelligence, they provide you nice or brief descriptions of these kind of functions like NumPy, matplotlib, or many other functions, by the way. So, therefore, you better try your hands, make some hands-on experience on how to use Scikit. In the open literature, there are many programs available which you can directly use it and type it. First, to install from the Scikit website, scikit-learn.org, and install this Python open source program in your laptop or PC, and then start using it. Okay, that is what I learned. Start using it, you will find different kinds of problems. You take a simple data sets and try to do regression analysis, or even Bayesian algorithm, difficult ones also you can use it. That is what is the main idea behind teaching you this. So, now let me go into the linear classifiers, because we are going to discuss some logistic regression, right, today I told you. So, as you know, logistic regression is basically a binary classification problem. You have learned about regression, right, you have probably done some assignment also on regressions. Regression is the simplest machine learning algorithm, okay, just fitting data. You have what is called X data and Y data. One is the variable, other one is your output, one is variable, other is called response. So, while you can fit this, right, you can use linear models, you can use nonlinear models, you can use complex models, various kinds of things I discuss. I do not want to get into all these details again, but logistic regression does not do that. Compared to linear regression, where it predicts continuous values, here it predicts the probability. So, therefore, it can have answer like yes or no, true or false, or 0 or 1, unlikely in case of other regression models where you predict continuous values of a function, right. That is the difference. So, therefore, in a nutshell I can tell you it predicts probability of a binary outcome 0 or 1 or yes or no, and you have to do that it use sigmoid functions, and this is very good for classification tasks. classify or non classify, 0, 1 or 0, right. If it is classified into your baskets, it goes to 1. If it is not classified, you throw it off. That is what is the idea. So, if I input features, you can have linear combination of the input features and then classify yes or no, right. That is the idea, no or yes. So, in fact, this is widely used in classification. First of all, what is this sigmoid function? What do you think it is? It is very important for you to learn some of these functions. Sigmoid function looks like this, okay. It is basically written the way it is written, phi z is 1 by 1 plus exponential minus z, right. That is what it is, very important functions. And if you plot sigmoid functions, you can see that it goes to 0 beyond 0.5, minus 0.5, also beyond plus 0.5, and its value varies from 0 to 1, okay. Very important function, right. So, let us say if my z is more than 5, minus 5 plus 5, it becomes 0. If it is between this minus 5 to plus 5, it can have values which are close to 1, right. It is not close to 1, as you can see here, it can have values between 0.2, 0.3, 0.5, 0.6, 0.7, 0.8 to 1, but you can think about it. If it is 0, you can remove it. If it is non-zero, you can take it out. So, people talk it that this is why it is, you can see there is a diffuse boundary between these two ranges, minus 5 to plus 5. You can see that the diffuse boundary, right, and this diffuse boundary sometimes can create problems. So, domain of sigmoid function is all real numbers. We can input any real number, the sigmoid functions, z can be any real number, it will give you a value. It has lot of asymptotes. As the x approaches a positive infinity, the value of sigmoid functions, so here it should be phi x, mistakenly I have written sigma x, phi x approaches value 1. Alternatively, if x approaches negative value, also phi x can approach 0, correct. This ensures that function never actually reaches 0 1, but gets an arbitrarily close. This is asymptotic, right. You can see here the plot is like that, asymptotically reaching 0, asymptotic 1. Third thing is the monotonicity. The sigmoid function is monotonically increasing. You can see that it is monotonically increasing, right, meaning that as the input increases, output also increases. As the x, as the z increases, phi z also increases. That is what is the monotonicity. Last thing is the differentiability. It is differentiable. Did you try it? Yes, exponential function is always differentiable, right, very easy. D phi by g z will be 1 plus, so d phi by dz is what? So, d phi by dz is nothing but 1 plus exponential minus z square, correct. It will be exponential minus z, right, because the minus z get cancelled. So, that is what is your differentiability, a differentiation of these sigmoid functions. So, hence it is very it's a very important functions when you talk about logical regressions. In logical regressions, we can always use these functions. So, I go back again. So, we predict the probability of binary outcome 0 or 1 or yes or no. I want to use sigmoid function to do that, right. Now, it is clear to you why using sigmoid functions and how we can use it, right, very clear. So, now let me just talk about little bit more on these aspects. So, logical regression actually can be different types, right. You can do different kinds of logics. I will go back to the board. So, you can have a binomial logical regression. Okay, this is we are talking about logical regression. So, it predicts 0 or 1. It predicts yes or no. So, there are different types of logical regression. First one is known as a binomial logical regression. What is this? This is used when the dependent variables is basically used as a Dependent variable is what? Here it's phi x, phi z, sigmoid function. Independent variable is, independent thing is z. So, dependent one is phi z. So, phi z is can be expanded as a binomial function. This can be, so I can write down that, right. So, you can always expand this in a binomial equation. Second is the multinomial. Multinomial logical regression. When the dependent variable has 3 or more possible categories, there is one category also. Dependent variable has 3 or more categories. For example, you want to classify animal into category like cat, dog or sheep. It extends the binary logical restrictions to handle the multiple class. Okay. So, the dependent variable has 3 or more categories. I give example, if you have 3 different animals, dog, cat and sheep, you can use multinomial logical regression. Third one is what? Third one is basically ordinal logical regression. What is that? This is used when the dependent variables has 3 or more categories with a natural order of ranking. Here, in the last case, there is, these variables are not order, in a perfect order, like cat, dog, sheep, it can be dog, sheep, cat, it can be sheep, dog, cat, not order. Okay. Let me write. Oops. Not order. Okay. But here, obviously there are 3 or more dependent variables. Three or more categories, and these are with a natural order. Order or rank. So, there are 3 different types of logical regression: binomial, multinomial and ordinal. In case of binomial, you have only 1 or 2 categories, one category is not correct, up to 3 categories, that is better to write, up to 2, not 3, sorry, 2 categories, because in the multinomial or ordinal you have 3 or more categories, but in the multinomial case these things are, or the dependent variables are not order or not in rank in terms of, here dependents are natural, as a natural order or rank. So, these are the different kinds of variables. How does this logical regression works? Have you ever thought about it? How does it work? Logical regression basically can be done using normal data. Let us do that. It can transform any linear regression into a logical regression. That is what is it. It is little difficult to understand into why it is little more abstract than the linear regression. But we can always use transform linear regression LR, we call linear regression function, which is continuous values function, right. This must be continuous valued function. We can convert this into categorical values. Am I clear? We can always transform these continuous valued linear regression functions into a categorical values, correct. So, one of the ways of categorical values is 0 and 1, right, yes or no or yes. Suppose you have a such a kind of a input features. This is a matrix form, right, input features x, input variables, and dependent variables y having binary values. It has binary values 0 if class 1, 1 if class 2. This is what it is. This is how I get x, which is dependent variables, it values like this, and y has two values 0 if class 1, 1 in class 2, right. That is what is very easy to understand. Now, if xi is the ith value, right, or ith observation, and wi the weights, these are different weights. You can go back to my regression analysis. You always put weights on each of these variables, and b's are bias. You can have bias, right. Bias is nothing but basically intercept, weights are nothing but slopes, right. So, you know that, right, y is equal to mx plus p, right. So, here this is your bias, which is nothing but a intercept, this is your slope, and this is your input and this is output. This is your input, I do not need to tell you, you know all this stuff, this is your output, right. That is what we write in linear regression equation. So, here I am talking about m in terms of w's, b is obviously bias. So, now a question is, so therefore, simply this can be represented as a dot product like this. So, we can write down y, let's write down y, okay, y as w, right. Remember, this is in matrix form, right. I done it in the last lecture. So, y is equal to w into x plus b. So, when you write in matrix form, this multiplied by all the w's plus b will come into picture, right. So, let me write down that. So, y is nothing but a y1, y2, yn is equal to this x function x11 go to x1n, x21, x2n, xn1 goes to xnn multiplied by w, w1, w2, Wm plus B's, right, P1, P2, Pn. That is what is this expansion of this equation in terms of matrix. So, now we have converted this. So, therefore, what you can do? Now, we can apply sigmoid functions on this. So, hence, I can write down sigmoid of this as 1 by 1 plus exponential minus y. So, you can get it. So, from this you can convert to sigmoid functions. So, therefore, linear regression can be easily converted to a logical regression, right, simply by this kind of small metastable aspects, right. So, so that means y, although y was going to provide me continuous values based on continuous values of x, I converted this y into a logical values by applying or putting a sigmoid functions onto the y. This is the main idea behind logical regression, or by using from the linear regression function, how can you get a categorical output. Okay, that is the main idea. So, obviously, this one sigma y tends to 1 when y tends to infinity. It tends to 0 as or when y tends to minus infinity, and it becomes between 0 and 1 basically bounded other regions. Okay, that is what is the plot you have seen for this function I plotted. Right, and I told you this is minus 5, this is plus 5. So, in this between this regime, this value is between 0 and 1 bounded values, but above this and below this it becomes 0 and 1. This is, remember, this is 1, this is 0, this is 0.5. Okay. So, that is why we can write, we can convert this way, this linear regression analysis to logistic regression analysis. This is very, very simple, and you must be able to do yourself, correct. So, that is one of the way to understand that. Now, since we are going to start, we wanted to start the decision tree today, but let me just give you an example. I already talked about it. So, what we discussed just now is a classification problem. We classify an object whether it belongs to 0 or 1, or you classify object whether it is a cat or dog or sheep, right. That is what the classification problem is. So, classification means subcategories, right. It is very important to do that. In material science, there are many classification problems, many. Today itself, I will give an example. There is supervised learning techniques. Main objective of these kind of things to build a model that can accurately assign a level or a category to a new observation based on whatever analysis you have done, right. So, you can have different images of dogs or cats, you can train your model by that. Then once you give a new picture, it must be able to tell you whether it is a dog or cat, right. So, it can be based on your color, texture, shape, anything, or maybe how does it look, right. Plant classification is already, I talked about it, can classify based on various kinds of things, and it can be either binary, just now we discussed about binary classifications, it can be also multi-level classifications, correct. So, you try to predict 0 or more neighbor classes for each example. So, there is no mutual exclusions because of the input examples can have more than one level. Well, so I just want to tell you one important things before I come back. So, we are going to discuss this kind of problems, because there is a large variety of materials and their mechanical properties can vary depending on material, depending on the processing conditions. How to choose the best material for a mechanical component? This is a difficult task. Can I use machine learning? Let us say we want to we have this kind of data. As you can see here, these are the different variables: cost, strength, corrosion resistance, weight, and name of the material is written. So I have given you in terms of low, medium, or yes, binaries, right? Low, medium, high, right? Or strength is medium, high, low, corrosion resistance can be yes or no, right? We can give you that. So now how can you design a material which is best suited for your purpose or a mechanical component? The rules, obviously, if you want to, you can have a high cost or medium cost, strength can be high, corrosion can be no, weight can be heavy. That's a steel actually. Steel is cost can be high or medium, strength is very high, corrosion resistance is not good, they are very heavy. Aluminum on the other hand is low cost or medium cost, medium strength or high strength, corrosion resistance is high, and they are lightweight. Then you can have composites, you can have also plastics or titanium. All these things are provided here. These are the rules. Okay. So simply you can make a tree like structures, like has strength, low, medium, high. Then for high you can create weights, low, light, medium, heavy. From light and medium you can make a cost, correct, low, medium, high. So aluminum comes here. So aluminum is medium strength, and then you can see it has it's a lightweight, cost is also low, right? You can build a tree like structures. If you look at steels, basically it's a high strength, it is weight is also heavy, and cost is not written here. So that's a steel actually. Titanium cost is aluminum cost can be medium, also titanium is basically high cost, correct. So you can actually make a decision in terms of a tree like structures. That is the idea of decision tree. Tree allows us to make decisions. So we will discuss more about this thing in the next lecture. I just wanted to give a hint what you are going to do in the next lecture. So let me stop here. Thank you.